Hello, my name is Khôi Nguyen, and I am a junior electrical engineering student at Prairie View A&M.
Hello everyone, my name is Stevenson Uzadima. I'm a junior computer engineering major at Prairie View A&M University.
Hello, my name is Mohammed Khan. I'm a junior electrical engineering student at Prairie View A&M University. Let's start with the basics. What is a microcontroller? Microcontrollers are used in systems ranging from the simplest lawn watering controller to highly sophisticated satellite systems. The average US household has about 60 embedded microcontrollers. Although the PC microcontrollers are the most visible, they account for just 6% of the microcontroller market. In the office, microcontrollers are used in computer keyboards, monitors, printers, copiers, fax machines, cameras, and telephone systems, to name just a few. In general, microcontrollers are used in applications requiring repetitive operation, such as running the traffic light at an intersection. In this application, the microcontroller's sole function is to turn lights on and off at predetermined times.
Today I will talk about the architecture of the PIC microcontroller. There are two most common architecture types that using in the PIC microcontroller. The first one is the Princeton architecture, which is also called von Neumann. This architecture uses the CISC instruction set, which stands for Complex Instruction Set Computer. In this architecture, both of the memory and the program memory, they coexist in the same address bus, but at different addresses. Voice loader is the half advantage of being relative, simple. This architecture is great for number crunching. And the second type of this is Harvard architecture, and in this one they use the RISC instruction set, which is stand for Reduced Instruction Set Computer. This architecture is more complicated than the Princeton, but it's also faster. The reason for this is because it can use the pipelining. The PIC microcontroller design with Harvard architecture and offer in many types. The standard is 8-bit wide, and the top of the line is 16-bit wide memory. In the architecture of the PIC microcontroller, it contains a lot of many components such as CPU, I/O port, memory organization, timer, counter, oscillator, and a CCB module, which is talk about the point.
The architecture of a PIC has many components, as mentioned. One of them being the CPU, also known as the Central Processing Unit. It is not unique in relation to different microcontrollers. CPU and the PIC microcontroller. CPU comprises of the ALU, CU, MU, and the allocator, and so forth. Arithmetic logic is basically utilized for number crunching operation and to take legitimate choices. Memory is utilized for putting away the guideline subsequent to handling. To control the inner and outer peripherals, control unit is utilized, which are associated with the CPU, and the allocator is utilized for putting away the outcomes and further process. Next is the random access memory, also known as the RAM. RAM is an unstable memory which is used to store the data temporarily in its registers. The RAM memory is classified into two banks, and each bank consists of so many registers. Next is the read-only memory, which is also known as the ROM. Read-only memory is a stable memory which is used to store the data permanently. In PIC microcontroller architecture, the architecture ROM stores the instructions or program. According to the program, the microcontroller acts. Flash memory is also programmable read-only memory, in which we can read, write, and erase the program thousands of times. Generally, the PIC microcontroller uses this type of ROM. Next, we have the stack. When an interrupt occurs, first the PIC controller has to execute the interrupt and the existing process address. Then that is being executed is stored in the stack. After completing the execution of the interrupt, the microcontroller calls the process with the help of address, which is stored in the stack and executes the process.
The PIC-16 consists of 5 ports, such as port A, B, C, D, and E, which all have a variety of input and output identities. Timers and counters. PIC microcontroller has 4 timer counters, wherein the one 8-bit timer and the remaining timers have the choice to select 8 or 16-bit modes. Timers are used for generating accuracy actions, for example, creating specific time delays between 2 operations. Oscillators are used for timing generation. PIC microcontrollers consist of external oscillators like RC oscillators or crystal oscillators. The value of the capacitor is connected to every pin that decides the mode of the operation of the oscillator. The modes are crystal mode, high speed mode, and low power mode. In case of the RC oscillators, the value of the resistor and capacitor determine the clock frequency, and the range of clock frequency is 30 kHz to 4 MHz. Here is a detailed list of all engineering properties that the PIC microchip contains.
An example applications of PIC16F84 is a street light that glows on detecting vehicle movement. The main intention of this project is to detect the movement of vehicles on highways to switch on a block of street lights ahead of it, and also switch off the trailing light to conserve energy. In this project, a PIC microcontroller is done by using assembly language or embedded C. The power supply gives the power to the total circuit by stepping down, rectifying, filtering, regulating AC main supply. When there are no vehicles on highway, then all lights will turn off so that the power can be conserved. The IR sensors are placed on the road to sense the vehicle movement. When there are vehicles on highway, then the IR sensor senses the vehicle movement immediately. It sends the commands to the PIC microcontroller to switch on or off the LEDs. A bunch of LEDs will be turned on when a vehicle comes near to the sensor and once the vehicle passes away from the sensor. The intensity will become lower than the LEDs will turn off.
In conclusion, microcontrollers have many great impacts. There are thousands of chips in every car, computer, and everywhere else in the world. They affect the way we work, play, and communicate. Without microprocessors, there would not be a modern society like today.